So the only thing different with a one-sided limit is the notation and that we're only looking from the left or the right. When we have x approaching some number, c, and we have a plus superscript, that means it's coming from the right. Okay, so it's coming this way along the curve. And if you think about a number line, where are the positive numbers? They're on the right-hand side. Negative numbers are on the left-hand side. So when we have the positive superscript, it means we're coming from the right. Negative superscript means we're coming from the left. Okay, and we've already said, based on everything we've done with limits, that for the limit to exist, these two things have to match up. So the limit as x approaches c, in general, is equal to L if and only if. That's what that IFF means. The limit as x approaches c from the right equals L and equals the limit as x approaches c from the left. All right, so let's find some one-sided limits. Now, what we want to do with one-sided limits is direct substitution, but we have to think about them a little bit harder. If I plug a -2 in here, I'm going to get 4 minus 4 is 0, square root of 0 is 0. But we're talking about -2 from the right. Now, I'm a visual person. So whenever I'm doing one-sided limits, I make a number line. What is a number a little bit to the right of -2? Just a little bit to the right. Let's go -1.9. If I were to plug -1.9 in here, instead of the -2, when I square it, I'll get a number a little bit less than 4, right? So then I'd be taking the square root of a number that's a little bit more than 0, right? Because 4 minus a number a little bit less than it, I'd be taking the square root of something a little bit more than 0. Okay, that works. So the answer to this is 0. But what if I asked you to do it from the left? Direct substitution would still give me 0. But if I'm just to the left of -2, say at -2.1, when I plug that in here, that's going to give me a number a little bit more than 4. So I'd be taking the square root of a negative number. And this one would be it does not exist. All right, let's look at example B here. If I did a direct substitution, I would get 5 minus 5 is 0 over 25 minus 25 is 0. And that indicates to me we can do something to figure this out. So we'll factor it. So the limit as x approaches 5 from the positive side of x minus 5 over, what would my denominator be? It's a difference of squares, right? X plus 5, x minus 5. So my x minus 5s are going to go to 1. And we're now finding the limit as x approaches 5 from the right of 1 over x plus 5 which gives me what? 1 over 10. Did it matter that I was coming from the right? Wouldn't it still be the same thing if I was coming from the left? As far as my simplified function's concerned, it would be, right? I mean, that's a whole, and on the left and the right of that whole, it meets up. Okay, so if we look at the square root function, we kind of talked about this just a second ago. If I'm coming from the left of 0, those are negative numbers, right? And I can't take the square root of a negative number, so this one would be does not exist, because those numbers aren't in the domain of the function. But coming from the right, we would just substitute in 0. We're taking square root of positive numbers when we're just from the right of it, and we would get 0. All right, let's look at example D. The limit as x approaches 3 from the left. Okay, so where the piecewise functions are tricky is trying to decide which row to use to evaluate. 3 from the left. So what's the number a little bit less than 3? 2.9. All right, so where would x equals 2.9 fall? In row 1 or row 2? 2.9 is less than or equal to 3, right? So for this limit, we're going to evaluate at row 1. So we'll plug in a 3 to that function, and we get 5/2. The limit as x approaches pi over 2 from the right of secant x. Now, secant is 1 over cosine. And cosine of pi over 2 is 0. So I'm going to get a number over 0, which tells you what about this? It's a vertical asymptote. And honestly, it doesn't matter if I'm coming from the left or the right. So just a little reminder of how you graph secant. First you graph cosine. And cosine starts high at 1, right? Goes to 0 at pi over 2. It goes to -1 at pi. Back to 0 at 3 pi over 2. And back to 1 at 2 pi. When we do 1 over that, that means anytime cosine equals 0, 1 over 0 will give me a vertical asymptote. And anytime cosine's equal to 1, so is secant, right? Because 1 divided by 1 is 1. So we take the maxes and the mins and we match them up, and then we approach the vertical asymptotes. So in this particular problem, when I'm approaching pi over 2 from the right, I'm hitting the asymptote, and that's it does not exist. If I was approaching from the left, I'd be hitting the asymptote as well, and that's it does not exist.